as you exit. And we're going to start on time now, and I'm going to introduce Guillaume, our Whisper team lead, Vlad Glahowski, and Whisper developer Guillaume Ballet.
Hi. So how do we switch on the...
there you go.
Okay. I strongly believe that the balance between liberty and oppression in our world is ultimately determined by the balance between offensive and defensive technologies. Imagine a world where defensive technology always prevails in every area of human life. Basically, nobody would be able to harm anybody else. Any kind of coercion would be impossible. Imagine the unprecedented level of liberty and security for all. And so, if we want to advance the cause of liberty, we should strive to develop all kinds of defensive technologies. And this is Whisper is all about. So today we're going to talk about achieving darkness with Whisper. So Whisper is a messaging system for distributed applications. And at the most secure mode of operation is supposed to be able to achieve darkness at considerable expense in terms of processor power, bandwidth, etc. So what is darkness? It's a property of the system when no meta information is being leaked. And it goes hand in hand with plausible deniability. For example, if the message is found on your computer, nobody can reasonably assume that this message was addressed to you because this is part of the protocol, that the node stores and forwards all the messages. So Whisper was designed to be integral part of Ethereum ecosystem, and it offers off-chain communication between the apps. So it has nothing to do with blockchain, it's off-chain. And the reason for that is because off-chain communication is much cheaper, and if you don't need consensus, you just need to send a message, you use Whisper. And so Whisper uses underlying Ethereum communication protocol to take care of message delivery. And Whisper is a gossip protocol. It means that every message is delivered to every node. So now we are going to talk about the technical details.
All right, thanks. Yeah, so this represents a network, and you have nodes on the network, obviously, and each node has a key. And if a node at the center wants to send a message to a recipient, what it does is that it encrypts the message with the recipient's key. And so it will then forward the message to its neighboring nodes, and those nodes will try to decrypt the message. They will fail because they don't have the right key, and they will forward it to their nodes as well, to their neighbors as well, and so on until it reaches the recipient that manages to decrypt the message. You will notice that actually this doesn't stop here. Even though the message has reached its recipient, the recipient will still forward to its neighboring node, and that's to not be identified as the recipient. Otherwise, that would leak metadata. So how do you, these are a lot of messages, how do you prevent people from spamming the network? We use proof of work. I assume I don't have to tell you what it is. But yeah, that's how you throttle the traffic on the network. So there are some advantages to this approach. First, it's decentralized, obviously, because you do not have to send it to one central authority like WhatsApp or Google Talk. You can also generate, you can also agree with the protocol on a protocol with your recipient on how to generate keys, so you do not have to store the keys on disk. And you have two other advantages, well, darkness and steganography, but Vlad will be talking about that later. We were not kidding when we said that would come at a significant cost. The problem of this approach is that it has a high latency, a high bandwidth. Obviously, everybody's sending messages to everybody else. There's a high processor load because you need to try to decrypt messages even if they're not intended for you. And on top of that, you need to keep a copy of the messages in memory because you might be sent messages that you already sent and you do not want to overload the system with sending extra messages. So you need to keep messages in memory a bit longer, and that's costly as well. So the way the message works, we have a time to live and an expiry, which is what I described, how long you should keep the message in memory. You have the nonce, which is related to the proof of work, and you have the encrypted payload, which is the message itself. And we also provide a heuristic to help the nodes determine if it's worth decrypting the message or not, to try to save a bit of processor load. So this heuristic is called the topics. It's 4 bytes of arbitrary data. It's very short. It's on purpose, and the goal for that is so that you cannot be identified with your topic. So other participants on the node on the network will probably very probably set the same topic, so you will be able to deny that the message was intended for you. In version 6, we also want to let the nodes decide what kind of topics they want to receive, and that will reduce the darkness, but that will also reduce the workload. So it's an help to improve adoption, so that people do not spend as much resources when adopting Whisper. And
So let's talk about achieving darkness. So we should assume that our adversary is very powerful and it owns a lot of nodes on the network, maybe more than half of the entire network. And also it is capable and willing to target individual nodes. So it can brute force generate the Whisper identities of its nodes in such a way that they fit into the network topology, completely surrounding the target node, and with the purpose of performing the traffic analysis. So for recipient, it's quite easy to achieve darkness because recipient gets all the messages, tries to decrypt them. In case of success, reads the message, and nobody from outside can detect it. The only thing the recipient should take care of is treat all the messages equally. So even those messages he can read should be forwarded. And if you use default implementation of get, then it's already taken care of. But for the sender, of course, in some cases, the adversary can see that the message was originated in this node. So how to achieve darkness? Well, you can try to maintain certain level of noise. For example, you send messages every so often, and if you have something to say, you encrypt a meaningful message. If not, then you encrypt some random data, and it will be indistinguishable. And also, I would recommend to use different topics and keys and whatnot for incoming and for outgoing messages. Because imagine if you have 2 nodes on the network, they communicate with each other, so you cannot really detect who communicates with whom unless those 2 nodes send messages with the same topic, or those messages share other traits, message size, frequency, proof of work, and so on. And so it's better to have that the messages outgoing and incoming don't share common traits. So message size is another important metric which can potentially leak meta information, and that's why we have introduced the padding field. So imagine that you maintain a certain level of noise, so you send messages every so often, and every message is approximately 1 kilobyte, and then all of a sudden you need to send a short message, like in this case, goodbye big brother, and then yeah, it's very different. So what you can do, you can randomly generate some data and put into the padding field, and then you encrypt the entire message, and those fields are indistinguishable, and so you can adjust the message size. And our default implementation already includes that, so every message has size which is factor of 256 bytes, but our API allows easy access to this field, so you can actually set any size you want. Also, our default implementation allows symmetric and asymmetric encryption for messages. In case of symmetric encryption, if you engage in this communication with somebody else, it means that you have already exchanged the secret key through some kind of secure channel. And I would recommend to use exactly the same channel, whatever it is, to exchange also the topics and all the other related information. And yeah, so it's easy. But for asymmetric encryption, what usually happens is you advertise your public key in some open channel, and you probably are not willing to publish the topic because, in this case, message sent with this topic, adversary can guess that the message was addressed to you. So, but if you try to decrypt all the incoming messages, it might be too expensive in terms of processor power. So what you can do, you can require higher proof of work for messages without a topic. And also you can advertise partial topics. So for example, you say, if the first byte of the topic contains certain value, for example, 0, then you will try to decrypt this message. I would also recommend to use the long-term keys only to establish the session. So you generate session keys for outgoing and incoming messages. You generate the topics, preferably randomly, and you send the first message to establish the session, and this message will be encrypted with the long-term key. And then you proceed to communicate normally with ephemeral keys. And after the session is over, the keys are deleted and nobody will be able to decrypt those messages again if you don't store them. So another important thing in our implementation is steganography support. So we have this padding field, and normally it's generated randomly, but our API allows easy access to this field. So what you can do, you can substitute the padding with some secret message. For example, you have some secret message, in this case lorem ipsum, and then you encrypt the message with some completely different key. You put the encrypted message in the padding field, then you compose some innocent looking message, like in this case, I have nothing to hide, and then you encrypt everything, and yeah, you get the encrypted message. And so in the future, if your communication is compromised, or worse, if the adversary will force you to reveal your long-term key, then adversary will decrypt the message, and they will see this innocent looking part and random looking payload. And they cannot reasonably assume that this message, this payload, this padding field contains some secret message, because all the whisper messages contain this padding field. So we are officially implementation agnostic. So what you can do with our implementation of Whisper, you can set up your own private network. And it has a number of advantages. First of all, in private network, you may have only trusted participants, so you don't expect any spam, and therefore you don't need any proof of work requirements, so you can abandon that. And also the number of nodes is relatively low, so you don't have bandwidth constraints, and so you will not have latency. And you can engage in instant messaging, you can engage in voice calls, video calls, whatever. And the only thing the adversary can say about the participant is that they part of this network. And in case of some organizations, it's already known. Also, some people ask me if it's possible to use the custom encryption instead of whisper encryption because they don't trust our whisper encryption. And I'm always happy to hear such questions because it shows that people are serious about security. And the answer is that you cannot substitute whisper encryption by the custom encryption, but you can encrypt on top of our default implementation, and our API allows easy access to do it. And in cryptographic community, it's usually discouraged to use custom encryption. But in this case, if you do it on top of our whisper encryption with unrelated keys, you can do no harm. And I actually want to encourage people to continue research and development in encryption because, first of all, we should not be complacent. And on the other hand, it's looking very promising. Actually, this is the first time in history that certain technology, namely cryptography, offers such a huge advantage to the defenders over those who try to attack. And of course, all kind of self-appointed busybodies are going to be very unhappy about it because they see the writing on the wall that technology makes them obsolete and they will no longer be able to control the free speech, and all the king's horses are not going to help them. And if you hear them saying that encrypted communication is very dangerous, and especially if they advertise their services to protect you from those dangers, just remember that we are talking about very peaceful technology here, which can be used solely and exclusively for defensive purposes. So here our contact details. Please join our Gitter channel or write to us on Gitter, and we will be very happy to assist, especially if your project seems to contribute to the cause of liberty. So we, of course, cannot help everyone, but yeah, we will try to assist whisper integration with any substantial project. And yeah, now we have a little bit of time, so maybe we'll take a couple of questions.
Yeah, Daniel.
Oh, Daniel. So one is the proof of work, and in Whispers version 6 is going to be dynamic. So you can dynamically set proof of work, and if traffic is too high, you can increase it on the fly. But also we will have Bloom filter exchange protocol for the topics, and so you will be able to set up those Bloom filters in such a way that you can probabilistically assess how many messages you get. For example, you want to reduce your traffic by 90%, and there will be formula how you can set the Bloom filter.
Right.
Yeah, please. Sorry? So
Yeah, can you repeat the question, please?
Yeah, how do you access the system? Just using a normal email? So if I just want to get some protection with my normal email, can I use this for doing it?
Can you answer?
No, sorry. It's a bit embarrassing, but could you please repeat slowly?
So I'm an Australian, so
Yeah.
put all my words together in one sentence. So
No worries,
Um,
mate.
yeah. So if I'd like to use this to protect my standard email, and I want to access this level of protection with my emails, how do I do that?
Right.
So I guess it's a question for the D-app developers. So those D-apps who use Whisper for their communication, they should take care of that. Maybe there will be some D-apps which provide email-like service based on Whisper, and maybe it's going to be status, maybe somebody else. So we hope it's going to happen.
Okay, so I'm just, I'm developing a D app that's going to have a front end in JavaScript connecting with Ethereum. So are you kind of envisaging that this gets implemented in a front end Java library to communicate with other peers around the network?
Jeez, it's pretty. So you want to use I didn't quite hear. So you want to use the Java?
Yeah, so they can even use it to spread heresy, apostasy, and all kind of dangerous things. And so why I mentioned those quasi-religious things is because
Yeah, but
government usually uses those.
yeah.
So my answer is that people did conspire and people did commit a lot of crime, and they use all kind of stuff to do it, roads and cars and whatnot. And so this is what we are doing. This is purely defensive technology. You cannot use it to attack somebody. You can use it to defend yourself, even if you're a criminal or if you're a normal person. You can only use it to defend yourself. And whatever the people will later say that is aggressive and whatnot, it's obvious that it's purely defensive, right?
All right. I suggest you come to us and we'll have a longer debate because we are running out of time and we have one more question.
How much can we expect the network to scale with our current computational resources, of the home users? In terms of how many nodes can we run so it's feasible for the network to support all that traffic?
Yeah, we're actually working on that one. It's pretty. Right now, given the protocol, it's still really really high. Like the load is really high, so the scaling is still a problem, and this is why we're going to introduce V6. So we don't have numbers yet, but if you're interested, we can keep in touch, and I'll send you the results when we start developing it.
Thank you.
Microphone. Thank you. Our next session is using Whisper and IPFS to improve customer experience in a peer-to-peer marketplace with Michael Thuy and Stefan Ponnet.
Hello, well, good morning. My name is King Forkel, Michael Thuy, and this is Bonnet, and we're with Swarm City. Where's the clicker? Do we have a clicker here? Yeah. I'm sorry, where do I click with this? Can I have the next slide, please? Oh yeah. Next slide, please. Oh, okay. Good morning. So, Swarm City. So just as many other Ethereum projects, we are trying to. Oh, is this one? Thank you. This is our vision, just like many other Ethereum projects. We want to enable humans to transact, create, and share value without a middleman or a third party on a global scale, generating contextual reputation. Our mission is to do this in a way where normal people like our parents actually understand what we are doing. So we don't want to have people experience the blockchain. Basically, we want to really make it really easy to use. Today we want to discuss two topics. We are trying to solve Ethereum-wide problems that we encounter in creating an app that is consumer-facing. So the first thing we want to talk about is the IPFS Consortium. The second one is the gas station. So the first thing, IPFS Consortium. So if you want to create an app like we do that's totally decentralized, you still need storage. We needed to find a way to have data persistence. So even if you do it on IPFS, you have to make sure that your data is persisted over time. The way we came up with that solution is really interesting, because it's the way we came up with solution actually is kind of the solution. It's collaboration, because it's key in the blockchain world. So we sat together with Givit in Barcelona and many other people, and after a night of brainstorming, we came up with this really simple solution. I'll pin your data if you pin mine. For an in-depth or a more in-depth technical overview of that solution, I'll hand it over to Spanat.
Yeah. Okay, good morning, everybody. So the solution we came up with for the IPFS Consortium is actually that we created smart contracts. So by the way, this works on top of another persistency consortium project by Piper Mariam. So we try to extend it a little bit and make it more general for that everybody could use it in like a more flexible way. So we created a smart contract, the IPFS proxy contract. And this contract will just emit events. So we have two events like hash added. So if an IPFS hash gets added or needs to be added to the consortium, it has a time to live, for example, and then the IPFS hash itself, and the hash removed function. So if you don't need the data anymore and you want it out of the consortium, so it's not pinned anymore, you can do that. Then in the smart contract itself, we implemented two functions, add hash and remove hash, which basically just emit these two events. So it's very low on gas to actually call these two functions. Then all these members in the IPFS persistence consortium, they will install a script on their respective IPFS nodes, which is a proxy listener, which is just a script that goes and listens to these events on that IPFS proxy contract. So that's the general setup. Now, there are a few more things there. For example, the IPFS proxy contract contains a list, sort of a whitelist, with all the members of the IPFS consortium members. So that means that all their public keys are in there. So it can actually verify if they call the contracts, so that only IPFS member hashes are pinned in the IPFS nodes itself. So there are different ways of adding your hashes to the IPFS consortium. So first of all, if you have a dApp or a script which wants to pin content, you can just call the function add hash or remove hash. So that's the way from doing it from your dApp itself for the front end. But we also exposed these IPFS events as a separate Solidity file, which you can just include in your own smart contract. So if the logic of your dApp actually needs to store IPFS content from on-chain, basically, then you can just create your contracts by implementing these IPFS events, and then the consortium members can add their contracts to the IPFS proxy. So it has a second list in there, and if they add it to the IPFS proxy contracts, then these proxy listener scripts will also start to listen to these same events in all the specific smart contracts that they use. Now concerning the governance of the IPFS consortium, so we don't want one single owner to manage the consortium. So that's why we added multi-members, so that's basically the multi-sig codes, to vote on adding or removing members. All the members, they pledge to persist each other's data, and they allocate an equal amount of disk space, so they sort of donate all an equal amount of disk space in the consortium. So it's interesting to notice that so we can deploy one of these contracts, which has a certain quotum, and all the members there, they say, okay, we are going to do this, like, for example, with a quotum of 10 gigabytes. But it's very easy to deploy a second contract, which then has, like, for example, a quotum of 50 gigabytes. So you can just choose to set up new of these contracts. Some of the future enhancements that we want to bring is that we can also do pinning via Whisper. So the idea is that you would just call or create a data payload in Whisper, which has the same command, so add hash and remove hash, which is the IPFS hash itself and the time to live. They will create a hash, and you will actually sign with an elliptic curve signature this payload. And you can just send it through a Whisper channel, and we can have then the script listen to this Whisper channel and just pick these things up. So to give a roundup on the IPFS consortium, so we have the possibility to do on-chain pinning by a smart contract. We can do off-chain pinning by the DApp or the scripts, which then performs a transaction. We can then, using the Whisper solution, also do off-chain pinning without a transaction. So just by signing it with your own key. We have the multi-member voting to add and remove participants, the data quotum. But on top of that, we also support that the network is permissionless. And maybe I'll give it back to King Fleur to explain that.
So that's a really interesting case. What's the next one? So anyone can run this proxy script at home on their own computers. And like we saw in Barcelona a couple of weeks ago when the Spanish government tries to block IPFS host names, we think it can be powerful that many people can actually have a voice and run this software just on their own computers. Currently, the IPFS consortium is, of course, in kind of prototype, or it's like we proved that it works, but of course we are inviting everybody to join us and to make sure that we can have data persistence in a decentral way. So the second thing we want to talk about is the gas station. So what we do if we want people to onboard our project, of course we send them some smart city tokens, but then we always have to say, and you need a little bit of Ether to actually do something with it, because every transaction, and then you have to tell a whole story about gas, right? So for a lot of people, like my dad, for instance, he was saying, why do I need 2 coins now or 2 tokens? So our ideal solution would be that it is a one-click solution in the front end, in the app, where people can actually exchange a little bit of their tokens for gas. Our design process is kind of funny, I think, because we always use the metaphor of a city. So if you drive around the city, you of course need gas, and what do you do then? You go to a gas station. I'm gonna hand it over to Sponet for this.
Yeah. Thank you. So the way many of the existing Ethereum projects solve it currently is by just giving away some free gas, so just sending some gas to a certain address which was created in a wallet, in the hope that they will actually use that gas to perform transactions in their ecosystem or to use their app. But most of the time you can't be sure if they will actually use the gas for that, or they just do some sort of Sybil attack and just try to collect as much free gas as possible. Another problem is also that if your app becomes very successful, you have to have a lot of Ether somewhere just to provide everybody with some free gas to get started. So we tried to come up with a solution where you can actually just do the exchange. We have like a durable solution that people just are able to pay with our tokens for getting the initial gas. So it's also a 2-part solution. So first of all, there's an API which needs to run, which is the gas station service. And next to that, we have a gas station contract that's deployed in lockstep with that. So people can actually just run it themselves. So first of all, you decide which ERC20 token you would like to support. So in our case, it's Swarm City token. And then you send some initial ether, which is just 1 ether, because it's just about providing initial gas, so it doesn't need a big amount of ether. You send it to the gas station, so you sort of fill it up with ether. So that's the setup. If you then have a dApp, so the use case here is that you have like a new user who someone just sent a couple of these Swarm City tokens, but it doesn't have any gas, so he can't do any transaction yet. So the thing he can calculate is how much way he will actually need to perform the first transactions that he wants to do to get started. So we will ask to the gas station service, what is your price for this amount of way that I will need? The gas station, he will consult a public price API to see what the current exchange rate is for Ether to Swarm City tokens. And he will reply to say, okay, this many way would cost you that many Swarm City tokens. The next thing that happens is that the device itself, or the dApp, will sign an allowance, which is an ERC20 function, to the gas station contract for that amount of Swarm City tokens. And on top of that, you will create an elliptic curve signature for all these parameters. So the amount of Swarm City tokens is going to give and all that. We'll go into depth a little on one of the next slides. So he will send this signed transaction back to the gas station service, and then the gas station service will verify that transaction, so we'll decode it, and if it all fits all the prerequisites, it will actually send gas to that address, so the address of the dApp, to execute the allowance call. When he sees that that gas has arrived, he will execute the allowance transaction by just putting it into the transaction pool, and when that transaction is mined, the gas station service will call a function in the gas station, which we call push fill. So let me quickly show like how it begins. It's not a complete function, but it's just to get you to give you an idea about how it works. So what does it give with push fill? So it provides a token address, so which is the ERC20 token that you support or you want to exchange. It gives a validity date, which is expressed in a block number. So this sort of personal exchange rate is valid, it has a validity period. We add a random number to create some entropy on the but that will come later also. You will say how many of these swarms tokens you can take from him in exchange for how many way in Ether you will give them. Then you also provide the gas tank client, which is the address of the dApp, so the wallet address from the dApp, and then the signature. So the thing that the contract will do, he will actually recreate that same hash with all these parameters, and here he will verify if the signature of all these parameters are actually match up to the address of the gas tank client. If so, he does the actual exchange, so the code is not here, and he will mark that specific, let's say, contract or that specific configuration to be executed, so he can't repeat it twice. Concerning risk mitigation, there's one problem, because you have to trust the gas station service that it will actually also perform the second transaction. So if you give him the allowance transaction, you must be sure that he actually doesn't, that he does that push fill thing. So to mitigate that, so I told you before that the API service responds with so many way, would cost that many swarm tokens. But actually, he's also going to give a elliptic curve signature on these parameters with his key, because it also has a wallet, obviously. And then we created the second function, which is called pull fill, and it will verify the same parameters, but will actually just verify if these parameters were signed by the owner. And this function can be called by the gas station, by the client who uses the gas station. So he has a certitude that if they do the exchange, they sort of mutually give the allowance to do exactly that transaction. So why would you participate, or why would you run a gas station? Because we can define, or you can define, an uplift for the price you sell your Ether for. So it means if you would, for example, say 10% uplift, if your gas station sells out, because the amount of Ether decreases, the amount of Swarm tokens increases, you will end up with, when you sell all your Ether, with an amount of Swarm City tokens which equals like 1.1 Ether.
So So the result of that is that anybody can just download that API script, deploy its own contract, prime it, we call it, with Ether, then configure it, like what ERC20 tokens do you want to accept in your gas station, then tell it how much Ether markup you want to sell it for, and just start it. You can find everything we are doing on these GitHub links, and also on thisis.swarmcity. You will find more information on everything we do.
But there's, of course, one more thing that we created. So, as you see, the gas station, it's at a certain time, it needs some maintenance because it needs to be refilled, because like the ether gets depleted in the end. We also try to solve that, and we have like prototype code of that, which you can also find on our GitHub. So we created an integration with Ether Delta. So the thing is that the gas station service itself, it contains a wallet. So when it has a certain amount of Swarm City tokens, and it's almost depleted of Ether, the gas station service can actually look into the Ether Delta and try to find a buy order for Swarm City tokens for Ether. So when he finds one, he will actually purchase it because it's like anonymous. I mean, you don't need an account or registration or whatsoever. So we just created like a machine-to-machine trading that actually buys Ether in exchange for his Swarm tokens. So the thing is, you can actually refill or automatically refill your gas station with Ether to start again. And closing that loop, so this can be fully automated, so you don't actually need to manage the gas station anymore, you just can have it run. When it does the exchange, you will actually end up with more Ether than you started with, so you will end up in this situation with like 1.1 Ether instead of 1 Ether.
So yeah, we thought it was appropriate to call that the gift that keeps on giving. So basically that is, thank you.
Yeah. Thanks for your time and for your attention.
So yeah, just we invite everybody to check out what we have been doing, and it was really an honor to be here. Thank you for that.
Thank you. Our next session is the Data Mechanics of Saving the Planet by Gregory Landau and Risto Karalainen.
Hi, everyone. I'm so grateful to be up here. So my name's Gregory. I'm here with Risto, and we're going to be talking about Regen Network. So I'm going to try to start on a pattern level to talk about what it is that we're up to, because we're doing something that I think is sort of a unique and unusual at this moment use case of blockchain and distributed ledger technology. So what we're up to is nothing short of completely reversing global climate change. How are we going to do that? Yeah. So how are we going to do that? We're going to create a large ecological data network, and a token system that incentivizes regeneration of Earth's soils. So, you know, I wanted to talk a little bit. I'm a farmer. I work with farmers. I've spent my whole life working with soil. So I'm not a developer. We have some amazing, talented developers on our team. But I sort of wanted to just ground this whole conversation. Everyone here depends on farmers 100%. So who ate today? All right. So there are 500 million small family farmers that feed all of us every year. And they're also the poorest people on the planet. And they also happen to be the only people who can save us from climate change. Unfortunately, centralized, compliance-based systems simply will not work. And I think we could all understand that in this room. So I'm going to show a really brief video that frames the carbon cycle and the potential of soil before we dive in a little bit deeper into the data mechanics of what we're up to.
If you're like most people, you're probably feeling a little hopeless about climate change and the damage we've done to our planet. Well, now there's a new way to look at climate change and how to deal with it that might just turn that hopelessness into hope. Climate change, as we know, is all about too much carbon in our atmosphere. But carbon is not our enemy. It's the building block of life. Everything alive is made of it, even us. The problem and the solution are simply a matter of balance. Let's step back and look at the 5 pools where carbon is stored on planet Earth. Starting about 500 million years ago, when plants first appeared on land, carbon began to cycle in an amazing balance between these pools, a balance that allowed for life as we know it to evolve. Then one life form, that would be us, figured out how to extract carbon from the fossil pool, which was pretty much a timeout zone for carbon. We've been burning it for energy, putting into play, and disrupting that balance. The way we manage land and do agriculture is moving even more carbon into the atmosphere. Specifically, we've moved 880 billion tons of carbon dioxide into the atmosphere, which is heating up the planet and destabilizing our climate. The oceans have absorbed a lot of this excess carbon, throwing off the ocean's balance, resulting in ocean acidification and accelerating a mass extinction of sea life. So in order to save life as we know it, of course we need to stop burning fossil carbon. The big question is, where do we put this excess carbon to get the cycle back in balance? The good news is that the answer is literally right under our feet. It's the soil. Plants, using sunlight and water, naturally perform photosynthesis. They pull carbon in from the air and turn it into carbohydrates, sugars. Then they pump some of these sugars down through the roots to feed microorganisms who use that carbon to build healthy soil. Voila, carbon moved. The plants pump it in and the soil stores it. Nature's living technology is amazing. Scientists have recently discovered that applying a thin layer of compost can help regenerate healthy soil, setting up an ongoing feedback loop that brings more and more carbon into the soil each year. Together with other regenerative practices like not tilling the soil, planting trees and cover crops, and planned grazing, we can build and retain billions of tons of soil carbon. This is carbon farming. This is regenerative agriculture. Unlike more carbon in the atmosphere, more carbon in the ground is good for us. It makes healthy soil, which is nutrient-rich and full of life and holds way more water. This means more nutritious food and crops that are more resilient in the face of drought. That's good news for farmers, families, and everyone who eats. Remember this, the way we grow our food, fiber, and fuel either puts carbon up into our atmosphere or pulls it down into the ground. The regeneration of soil is the task of our generation. Our health, the health of our soils, and the health of our planet are one and the same.
Well, I don't know about you guys, but that gets me inspired every single time. Because that's a big, crazy problem, and it turns out it's actually not that hard to solve. The challenge is being able to verify what's actually happening on a farm so that we can support farmers and incentivize them to be actively sequestering carbon. So I just wanted to go through a couple numbers here to sort of frame the bigger problem and hopefully show how completely achievable it is. So the world's soils have 320 gigatons of carbon storage capacity. We only need to sequester 128 gigatons over the next 20 years to completely reverse global warming. Wow, okay, there's 500 million small farmers, so we need roughly a third of those people to be participating on our network in our program actively regenerating soils. So, we've been working on two core aspects of our protocol. One is proof of regeneration. So that is the ability through farm IoT sensors and satellite protocols and drones and user smartphone interaction to be able to prove what's actually happening on any given farm in a decentralized way that is not owned by any central authority. And two, creating a reverse mining protocol. That is the ability to mint tokens by proving that you've done something that's in the public good, which is sequestering carbon into your soils. So those are the two foundational pieces of Regen Network. So we're going to spend I'm going patterns to details here. We're going to spend a little bit of time coming right up with Risto going through one of our pilot projects, which is actually calibrating the proof of regeneration protocol at this moment with real-time sensor data from a farm in New Hampshire. We're actively working right now on some of the scaling problems. Our network is going to have to be sharded. There's no way around it. And we also have to work a lot on identity because you can't have, we actually have to have proof of identity, proof of location as a core part of our whole protocol. So just to sort of frame some of our technical challenges, we're looking at validation of claim and outcome as a core part of the protocol, verification of location, identity, the ability to validate data authenticity, and also verify data integrity. So I'm going to hand it over to Risto here so that he can talk a little bit about the role that Streamer is playing in helping us develop a market for this highly valuable ecological knowledge that drives the incentive for farmers to be participating in this program.
Thank you very much, Gregory. It's great to be here. Gregory, of course, and his team are the experts on regenerative agriculture. Where Streamer comes in is on the data side. There, the key aim is to verify if the conditions are conducive to carbon accumulation in the soil. To answer that question, you need lots of data from various sources, and that's where we at Streamer can help. There's a number of things which can be monitored on a farm. Taken together, such measurements give a pretty good indication of soil health and equilibrium. And that's important because the carbon sequestration is one of the core functions in a healthy soil. Now, we've got lots of data in here. I won't go through that all. Just to mention, some of these are low frequency, like satellite images, soil sampling. Some are higher frequency, like temperature measurements, numbers on electrical conductivity and so forth. But the thing is that you need to combine data from many different sources. In here, low-cost sensor data are important in the calibration of the lower frequency carbon sequestration models. In practice, what you have to do is to collect, transmit, and analyze all of the data in real time. That's what we have here is the data mechanics, how it works, where Streamer fits in. You start with planting the sensors in the soil. That's typically done, maybe not by the farmer, but by kind of specialized agri-IoT companies. Next thing you do is every time sensor goes live, they send the data points as JSON to Streamer endpoint. And then Regen Network subscribes to the data as it arrives. in here. They analyze the data in real time, calibrate the models, verify the carbon sequestration. What happens in between is that the data automatically kind of flows through the peer-to-peer streamer network from source to subscribers. The nodes in the network are incentivized by getting paid by data token for their efforts. Moving on, each data point as it arrives is timestamped, appended, persisted in a stream. This is kind of the user interface of the streamer system. The concept of stream makes it easy to later analyze the data, do historical playbacks of the raw numbers and the analytics. Thank you, Gregory. Let's just move on, and I'll quickly show you an example of how the data playback works on the streamer platform. Here we run through the sensor data from early July until a few weeks ago on the ham farm in New Hampshire. The final point I'd like to make is that the same data can be valuable to many different audiences and data consumers. In this case, of course, the regen network is the prime user, but there's value in the data doesn't stop there. Apps, companies can subscribe to the data, use it for services such as day-to-day farm management, performance monitoring, yield optimization, irrigation, harvest forecasting, and so forth. You can even think if there's any kind of financial people in the audience for other uses, like having real-time information about the state of the crop, weather events, which can be immensely valuable for commodity traders, insurance companies. With that thought, let me hand back over to Gregory to recap.
Thanks, Risto. So, we believe that what we're working on here is creating a marketplace where farmers own their own data and can sell it at a premium to all of the people around the world who need that data, from governments working on climate change initiatives to people who want to anchor supply chain transparency into their relationships with customers, to commodities traders, as Risto is speaking about. But fundamentally, the beauty of the project is, as those tokens are used to access this data, the price of regen tokens remains stable or goes up, which incentivizes farmers, who are the only people, as I noted earlier, who can mint new tokens. So the only way that a new regen token ever is going to come into circulation after the initial token generation event is by a farmer proving that they've regenerated soil. So all of a sudden, farmers are back where they should be, which is at the center of the economic system as the people who are providing the base layer of wealth for everything else that's taking place. So we're really excited about that. We're really excited to be moving forward with new pilots in very challenging conditions. This is a photo of a farm in Ecuador that we're about to be starting another pilot on. So working with cacao farmers to measure the carbon cycle and carbon sequestration dynamics in their ecosystem. And I sort of just want to leave everyone with an invitation, because what I've learned here at Devcon3, which is my first Devcon, but what I also know from my work with farmers all around the world, it is all about collaboration. And the beauty of this space is open source, collaborative approach to big engineering problems, and I know we have a whole stack of them. So we're looking forward to being members of this community and continuing to work on this amazing potential to have blockchain-driven, community-empowered solutions reverse climate change and many of the other big problems facing humanity. So thank you all very much.
Hello. Next up this morning, we have Anton Galenovich, PhD, and Sergei Longshov with the presentation Decentralized Autonomous Organization, Integral Platform for Climate Initiatives.
Hello. Can everybody hear me? I'm not sure it's working.
This is clicker. Yeah.
Okay, we're going to continue the previous topic about the environmental risk, damages, and climate change, but from a bit different approach. And thanks to my colleagues that were speaking before us, we can, bypass the first slides. But the difference of the approach is that we consider the environmental damages, including climate change, as in fact a damage which is caused by human economic activity in a general sense. So more specifically, every deal, transaction, or contract has its collateral damage. And when you buy a gas or air ticket for your air travel, there is a collateral damage to the environment, to human health related to it. And in fact, in the nearest years, it has already become a business custom to assess the damage related to any sort of economic activity, transaction, deals in terms of carbon dioxide equivalent. It is a very convenient thing to evaluate environmental damage because it reflects not only climate change damage, but also combustion of fossil fuels, air pollution, energy efficiency, and that's why it's not only important, but very convenient thing to quantify the environmental damage. For example, a few years ago, there was a notorious study evaluating the damage related to indoor cannabis production in the United States, and the damage is, as you can see, the energy expenditures equal to $5 billion, 1% of electricity consumed in the US, and 1 kilogram of indoor cannabis production equals to 4.6 tons of CO2. And the recommendation was to legalize marijuana because outdoor production would eliminate the need for indoor production. So that's the basic scheme that we're talking about. There are three principal participants of the model: the seller, the buyer of goods and services, and there is a mitigation outcome provider. And the mitigation should be equal or greater than the collateral damage produced by the deal between buyer and the seller. And once these three participants agree on the amount of damage and on the price for mitigation outcome, then in the ideal world, the problem would be settled and solved. But in real world, it's far more complicated because there should be someone who evaluates, assesses what the collateral damage is, and there always is a person or an entity who wants to be in charge and tell the buyer, the seller, and offset provider what should be settled, what shouldn't be settled, how the damage should be assessed, and everything. There is a regulator who wants to be in charge. And that's why, although this market for mitigation, for example, of climate change damages is is tremendous, and it's, at maturity it will be at least $10 trillion. And, but it is fragmented into pieces, and numerous barriers prevent from, fungibility of the instruments. There are dozens of climate mitigation programs, and new programs appear, and units and instruments, carbon units, and I guess that one of the example was a previous presentation that a new, very interesting program and a new carbon unit is proposed. But basically, they all operate with one and the same unit, one and the same asset, 1 ton of carbon dioxide emissions or 1 ton of carbon dioxide reduction absorption. But they are not integrated. And the regulators really, choose and select who can assess the damage, who can participate in the market. And our initial target was and still is to provide an opportunity to overcome the barriers, external barriers between those dozens of markets and systems and registries, and to internal barriers which do not let anyone who would want to participate really participate in it. So that's why we've created a platform that allows anyone or any existing or new mitigation program to launch its program on blockchain and to, cooperate, integrate to the extent they want to. They might be fully independent, or they would want to merge the markets, or they would want to have a unified token, a unit. But any of those dozens of markets, carbon programs or instruments, carbon compliance units may enter this blockchain, and anyone can actually right now go and launch his own mitigation program. So what we have achieved for the moment, we have, transferred the units from a conventional registry to the blockchain and performed pilot transactions. And we have also performed a issuance of environmental units of carbon credits bypassing a conventional registry directly to blockchain, which is not easy because in a real world, well, you still have to, to have a very reliable auditor. In our case, it was KPMG, to verify, assure that those reductions are real and comply with the rules. So actually, right now, you can enter the decentralized application to trade or to retire, to offset the carbon footprint or launch your own program. In fact, as cryptocurrencies also have quite a significant carbon footprint. And for example, the Bitcoin network related carbon emissions are equal to those of emissions of Cyprus, and Ethereum network are smaller. Emissions are smaller, but still they equal to the annual emissions of Moldova. So it's pretty easy to imagine that there is there might be a token proposed to offset the exact amount of emissions related to 1 Bitcoin or to 1 Ether. We have a very vast, development plans, and developing the smart contracts and everything. But for the moment, we might say that the proposal of a high-quality assured environmental units is already provided at the platform. Now that we are working on the demand. As I've described, the problems related with regulators, registries, opposition to a new technology that would basically deprive the regulators of much of their authority and would probably kill the traditional registries, so that doesn't go easy. And one very important thing is to, in the strategic perspective, to eliminate the need for really physical auditor verifiers participating in this process, and substituting it by Internet of Things algorithms plus a validation by the network. And from this point, I'd probably like Sergey to take over.
Good day, my name is Sergey Onshakov. I'm research team leader at Aerolab and DAO architecture in IPCI project. My part of presentation will be about how we can prepare Mars for Devcon3. As you know, Mars today is not a good place for humans. It's a very cold place and atmosphere is not friendly for our breath. And if we resolve issue with logistics, with the SpaceX or other space program, next question will be, can we make Mars a little bit comfortable for Devcon3? And it will be a surprise for you, but Paris Climate Agreement can help us. Because if you try find some abstract or executive summary about Paris Climate Agreement, you will find main task of Paris Climate Agreement. Main task is keeping a global temperature rise below 2 degrees Celsius. And it means the Paris Climate Agreement is the first planetary terraforming experiment based on economical game. My main work is research capability of using human-to-machine systems. And the last 3 years we're working on robot economies concept. We want to build first planetary supply chain with direct economical communication between humans and machines. But Paris Agreement today is not a human-to-machine system, it's a human-to-human system with strong reputation requirements. And these requirements for me is ridiculous because we cannot do planetary experiment with this requirement. But if we shift Paris Climate Agreement on Ethereum network, Paris Climate Agreement can be human-to-machine system. And look at the screen. I will try to explain how it can be work. We have manufacturers around the world who want to be involved in Paris Climate Agreement. At the same time, we build smart cities around the world. And these smart cities have many types of different sensors what can collect data about carbon footprint around manufacturers. Smart cities can send annual reports to Ethereum network. We can install additional package on Ethereum network validators, additional package with carbon credit emission algorithm. And after that, Ethereum network can issue carbon credits. Green humans can buy these credits, and our collected funds can be spread between green economy manufacturers, smart cities who collect data, and Ethereum network validators who involved in this process. And if it will be work, we just can change terraforming task from Paris Climate Agreement to prepare Mars to Devcon3 with the same scheme is the same software. So today we have a smart contract package for carbon credit market tested with real participants. We built a decentralized application for human-to-human communication, and My team, AeroUp team, now try to build first carbon footprint sensors network with Ethereum network validators based on our area distributive. In the next year, we will show first algorithm for carbon credit issues based on Ethereum network, and we want to build first service for reducing your carbon footprint only with carbon credit based on Ethereum network. Here you can find more information about project, and if you're interested in area distributive, you can find more information on area.live website. So keep on the way to Devcon on Mars, and we will try to prepare and doing Mars more comfortable. Thank you.
Hello. Up next this morning, we have Greg Dugarian, sorry, I hope I pronounced that correct, with his presentation, How Crypto Payroll Can Improve the Plight of Temporary Workers.
Claudia Martinez is a young woman from Guatemala. She works in a pickle processing plant in Pittsburgh, and she's a temporary worker. And for most of the day, she does this. Can any of you guess what someone who does this on a pickle plant's assembly line is doing? Yeah? She's a brine displacer. She removes a certain amount of brine from the jar so that they can screw the cap on and move it on its way. Sounds pretty bad, or pretty unpleasant type of job. Well, it gets worse. Claudia works Monday through Friday, usually 40 hours a week, and she doesn't get paid till the following Thursday. That following Thursday, she gets a paper check, and after work she drives down to a check cashing place and she pays a fee. Takes her about a half an hour to get fiat currency. And then she drives again to go to a wire service place, something like Western Union, to send some of that money back home to her mom and 3 sisters in Guatemala. Again, more time, more fees, usually $10 to say send $100 back home. Pretty bad, right? Right? The fiat system gets worse than that, though, because Claudia has waited so much time. Unfortunately, she's organized. She doesn't have to resort to this, but there are 10 to 25 million temporary workers living similarly in the United States alone, and many of them can't wait to get that money. They can't wait all that time, so they take recourse to something called a payday loan. Have any of you familiar with payday loan? Yeah? We probably know it's a very expensive, unpleasant thing because a lot of times these people never get out of the hole. They're constantly paying more and more interest. It's a real sad situation. The current fiat system, Jamie Dimon and his band of crypto capitalists and their fiat system is screwing these workers. And we need to fix it in crypto. Thank you. So, a little bit about me. I'm Greg Dugarian. I'm a founder of TempWorks Software. It's a software system that my dad and I wrote in the early 70s and have been evolving from the early microcomputers, and now my oldest children run the company. We're based in Minneapolis. But it's very simple on a mature payroll system to simply add an adjustment that would go to a crypto pay card. Of course, we have a number of challenges in this system right now. First of all, these pay cards aren't universally available. We need them to work not just in London or New York, but also in a remote village in Guatemala. We're talking about tens of millions of transactions a day that we would need to be able to process for people to really take advantage of. So I have a lot of challenges ahead of us. By the way, can I get a show of hands? How many people have worked a temporary job in their life? Wow, well, it's almost everyone. I was thinking, okay, these people only worked per hour coding something, but so you know what a tough job is like. Sometimes I feel my toughest job ever was to get Python Ethereum to work on my Macintosh. So anyway, TempWorks, we've developed 2 different products on the Ethereum platform. One is, if you're familiar with DocuSign or HelloSign, it basically allows you to create a contract, have different parties sign it, post it to the blockchain. I put a note up on the Ethereum Reddit about that if you want to check it out. The other is this crypto payroll system. And basically it's wired together right now. I got into this in 2015 because I was employing a large number of Filipino virtual assistants who were setting up sales appointments, and every Friday it was me who was going to Coinbase and paying $50, $100, $75, and these people were perfectly happy to accept crypto. You want Coinbase users here? How many like the interface? Yeah, no hands that I see. It's pretty hard to do that using most client software for sending crypto. So the idea here would simply be that our system, as it evolves, will simply be paycheck, just like any other paycheck, with an adjustment that instead of going to your retirement account, would also go to your crypto account. It's something that we need to do. We need to do this for humanity. We need to do it for all these temporary workers. We need to make it so that we're living in a world where instead of Claudia spending all of her extra money and time driving around dealing with the fiat system, instead she's studying Python and Ethereum and is going to develop the next generation of our crypto solutions. I'd like to thank the Ethereum Foundation, Mexican government, all these wonderful workers who've made the conference so nice. I'm just blown away by the quality of the other presentations. I feel real honored to be up here. But I think I'm really eager to hear from any of you who can help me advance this solution and make it become a reality faster. Thank you very much.
Okay, next up we have Human Haddad with his presentation, Blockchain for Humanitarian Assistance.
Good morning. My name is Human Haddad, and I'm here to tell you how the United Nations World Food Programme is using Ethereum to distribute aid to refugees. The WFP's mission is to end hunger, and traditionally this has been simple. Where people are hungry, we bring food in kind, like corn, rice, and so on and so forth, and we give it to them so they can eat. For a few years now, we've also been doing something what's called cash-based interventions, which means that instead of giving people food in kind, we give them the means to purchase their own food. And this can take the form of bank cards, mobile money, e-vouchers, and so on and so forth. And the idea behind it is that the beneficiary is in the best position to make their own purchasing decisions, so that essentially, instead of saying, okay, here's some food, eat this, they can make their own choice, and there's an element of dignity in there, and also that it can have a multiplier effect in the local economy. In order to enable this sort of modality, we normally have to rely on financial intermediaries, such as banks, mobile money companies, and cash agents. So what the services that these financial intermediaries provide falls under two broad categories. One is practically accounting, which is creating accounts for beneficiaries, providing a distribution mechanism such as SIM cards or bank cards and so on and so forth, authorizing transactions when beneficiaries spend their entitlements, and then eventually reporting to us. So this, let's call it accounting overall. And separately, it's actually paying the supermarkets or retailers where beneficiaries have made the expenditures. So a typical setup could be that at the beginning of the month, the WFP gives a list of beneficiaries to the bank saying, here's our beneficiaries, here's how much each one is getting, and they will create the accounts and load them. And we also have to advance money for usually a month to the bank to enable this essentially transfers to happen. The bank then contacts the beneficiaries saying, here's, you got some entitlements. The beneficiary goes to a store, initiates a transaction. The store pings the bank for authorization. The bank checks the account. If they have enough entitlements, they confirm back. And then eventually, post factum, on a periodic basis, the bank will pay the store for the actual transactions that have taken place. And let's say at the month end, we get a report from the bank saying, okay, this is what actually happened. So a number of issues that exist with this model. One is cost. Of course, the bank will charge a fee for this, and at our volumes, that cost can be quite high. There's the element of risk, because we're advancing money to the bank, and especially in the kind of places that we work, that risk can be quite elevated if the bank goes bankrupt or commits fraud or whatever. We have to share beneficiary information with the bank. They need to know essentially who they're opening an account for, and privacy could be compromised. There's the issue of reconciliation. So when we get the report back from the bank, we make all sorts of efforts to verify the report to make sure that the transactions that they say took place actually did take place. And this is very laborious and time-consuming, and we can never really be 100% sure. There's the element of control. So normally for everything we want to do to add a new beneficiary, increase entitlements, whatever, we have to formally advise the bank, and they would do it on our behalf. And in addition to the administrative burden, there could be a time delay, which could mean somebody goes without food for a while. We make a lot of effort to reduce our financial risk and also to protect beneficiary privacy, but this also means the contracting can take quite a long time, which again would delay operations. And then there's the issue of flexibility. So for example, if we wanted to do e-vouchers and mobile money and ATM, and these companies don't talk to each other, and we don't know in advance where beneficiaries are going to redeem their entitlements, we can't really enable this. I mean, the best we can do is, divide it a third, or half and half, but it's not ideal, so it's not quite flexible. So what we've done essentially is replace the financial intermediary with blockchain. And so what we do is now we load, create blockchain accounts for beneficiaries, load them with the entitlements. We inform the beneficiary they have entitlements that they can use. They go to a store, they initiate a transaction. The store now pings our blockchain instead of the bank for authorization. We check the entitlements, provide confirmation. And then at the same frequency that the stores got paid before, we know essentially which store to pay how much by when, and we make the transfer to the store directly ourselves. Just a clarification here, we have bank accounts, and this transfer currently is happening through regular banking channels. In the future, it could be crypto, for example, or a digital national currency. But the difference is that we have 350 global bank accounts that we use for, making staff payments, buying corn, and so on and so forth. And the cost of payments directly for us is really cheap. The main expense to us with the previous model was this accounting, issuing cards, POS terminals. That was essentially the main cost. So just to clarify that, we have our corporate bank account where our bank accounts are, and then usually we had to have a separate bank to provide those distributions, and that's what we've replaced. So we did a quick proof of concept in the Umerkot village in the Sindh province of Pakistan in January. And based on that learnings, essentially, we've launched a pilot in the Azraq refugee camp in Jordan since May this year. In the past 5 months, we've been assisting 10,500 beneficiaries. We've distributed $1.6 million, 200,000 transactions without a glitch, and we've reduced the fees essentially by 98%. So that is what that accounting portion cost us, and the 2% is what's costing us to make these direct payments. In the future, with crypto or something else, that could even go maybe near zero. We're not sharing any beneficiary information with anyone. So again, in a refugee context, that's very important. We're not advancing any funds to anyone, so our financial risk is greatly reduced. We have full control, so if we want to change entitlements, add someone new, we can practically do it in real time, so the assistance is not delayed. And very importantly for us, we've authorized every single transaction, so we have 100% certainty that what we think happened actually happened, and that significantly improves our reconciliation process and the associated payments, so it actually reduces the effort on our side. Then because we don't have to worry as much about financial risk and privacy protection, then we can actually contract people faster, which means we can operate faster. And we're much more flexible now because all the accounts are on blockchain. We can connect to as many outlets as we want, and they're all coming out of the same wallet, so we can provide that flexibility to beneficiaries, which again, it's great. So you might ask, why are you doing this on a blockchain? You could do this essentially on a traditional system, and that's completely true, we could. But one of the main reasons is that there's currently a lot of fragmentation and duplication in the system. And this is only for illustration, but essentially imagine if we have Bob, and Bob is receiving assistance from 4 different agencies. Each agency would have their own identity system for Bob, they would have the contract with a separate bank, and they would channel assistance through each one of these. And of course, there's a cost and the effort required to maintain all these systems, the contracts with the bank, and they don't talk to each other, so that really things are not optimized or harmonized in a way. So what we're hoping to achieve, and actually one of the reasons this exists is that the technology in the past has prevented collaboration among the agencies, but it's various ownership issues. So if we have a system and we have a contract with a bank and someone else has something else, we don't want to use theirs because it's not cool and vice versa. And what we hope is that blockchain can cut through that as a neutral, mutually interoperable, equally owned, all of that, open source system. Then it's not really owned by anyone, but it's just a mutually operated system that everyone can use. And this way, we can have beneficiary, let's say, identities or wallets on the blockchain for Alice, Bob, Dave, and Aaron. And various UN agencies can link to that and provide whatever service they want to provide. And giving our various networks, like for us as WFP with food retailers, someone else might have health network like hospitals, schools, whatever else it might be, we can really dramatically increase the convenience to beneficiaries. And if we're all using the same system, we can really optimize and harmonize the global aid effort into an unprecedented degree with big data, artificial intelligence, whatever it might be. And I think extremely importantly is the element of financial inclusion. I mean, even now, without using crypto, we were adding quite a bit of that to the people who may not have a bank account before. But with the advent of that, investments, loans, microloans, insurance, international remittances would be available to many, hopefully soon at a low or no cost. Another reason why blockchain is that essentially, so we have now, let's say, an identity for a person on a blockchain, and we as WFP are adding financial transaction histories to it. And just showing that you can spend money is not very meaningful, but if you show that you can save a little bit of it, that might actually count towards a credit history. And this credit history now is not tied to a specific financial institution, let's say in Jordan. So if a Syrian refugee were to go back at some point, they could transport this history with them and maybe get a small business loan and get back on their own feet. If we manage to then bring other actors on board, we can maybe add education data, health data, asset registries, work permits, and make this profile increasingly more and more useful to the beneficiary wherever they are without the fear of persecution, for example, because of their origin or whatever else it might be. And I don't think it's unfeasible to think that one day maybe even government IDs could end up on the blockchain. And we've heard here a lot of things about privacy protection, zero knowledge proofs, and I know it's at an early stage, but essentially this is the path we've just started, and we hope as technology advances, connectivity becomes widely available, the price of smartphone goes down. In a few years' time, this could be a full-fledged, essentially, tool for beneficiaries to have more convenience and flexibility. So our invitation is to other humanitarian actors who don't have a profit model built in, is to not to reinvent the wheel. So we have nodes set up, we have essentially smart contracts for cash transfers, and we're asking if they have resources, they join us open source, free, and dedicate their resources to making the system better, more secure, add additional modules like identity, supply chain, health, whatever, and also make it available for free so that it can essentially grow to be a system everyone can use. Currently, we're using a private chain, and mainly that's because the transaction throughput that we require can't be handled on the public chain. But one day, philosophically, we're leaned if we can ensure security and privacy and all of that to move there so the system is self-sustaining and doesn't even require the backing of WFP or the UN or whoever else for it to function. So yeah, please join us to empower the world's vulnerable. We really look forward to collaboration. This is a photo from our proof of concept that we did January of this year in Pakistan, essentially. And for this, we used the test net to distribute food and cash to these beneficiaries, essentially to illustrate the point that it can be done. And using that learnings, then we've done our Jordan pilot, which is now going well. It's 5 months in production. And we're soon going to scale up to 100,000 beneficiaries, and a few months after that to 500,000, which is all of Jordan. And from there, other countries could follow that have, that could potentially benefit from this solution. I have many, many people to thank. Of course, WFP itself for providing this safe space for this idea to take root. The Ethereum community at large, who has been very supportive. The Ethereum Foundation for allowing me to be here today and get this message out. And also, Rich Bodo, Rich, put your hand up, who we met at the Singularity University around this time last year, where this was just an idea and we had very little resources and support, and we told him about it. He helped us think through it, and he pretty much hacked together what we used in this proof of concept in the photo that you see, and he did it for free. No matter how much we insisted, he didn't accept any funds, so in a way, he gave us that initial push that we really needed to get this pilot flying, essentially. My email address is there if anyone is interested in more information. And since I have a few minutes left, I would actually like to show you a video of how the system is currently working. So in Jordan, they happen to use iris verification even before we went, so we wanted to seamlessly integrate into that so we don't change the beneficiary experience, especially if we were going to fail and the system would have to be rolled back, essentially. So what you would see here on one side is the cash register at a supermarket in one of the refugee camps that, they ring up the normal bill, the amount comes up, the amount is put into the iris scanning terminal, the beneficiary scans their iris, that iris then goes to be checked against an identity, the identity comes back, and at that point the terminal has both the amount and the identity of person trying to do it. They ping our blockchain, can this person do this transaction? We reply, and that's essentially the a lot of oranges. Okay, on the bottom right, you briefly see the amount, 1280. Beneficiary scans their iris. Transaction goes, the iris imprint goes to the database, comes back with the identity. Now it's coming to our blockchain with the amount and the identity. And that's it. I have 4.5 minutes, so maybe 1 or 2 questions. I think there was one already there.
So, well, in this case, you have this iris scanning infrastructure.
Yes.
But in general, in order to have a established blockchain identity, especially a long-term one, you would need a private-public key pair. And do you have any solutions in place providing people with public-private key pairs in such a way that they can control them and they have adequate security with them?
Yes, so good question. One of the things we cannot assume right now is hardware and connectivity for everyone, especially where we are right now. In fact, the internet is cut off. Again, we're building towards the future. So as you might know, Google, SpaceX, OneWeb, a whole bunch of people are working to bring affordable satellite internet everywhere in the world. And the price of smartphones is dramatically dropping. So I think by the time we're ready, the standards for identity have been sorted out, zero knowledge proofs, whatever. We can then transfer beneficiary private keys to them, potentially on their devices, and the device could even have a biometric authentication to trigger the private key, but for it to be, the data to be stored with each beneficiary and not centrally. Not sure if I answered the question. Yeah? Cool.
Hi.
Yeah.
I'm working with a group in Bangladesh handling the refugee crisis with Burma or Myanmar. It's about 1.5 million people. First question, how many beneficiaries can this scale to?
Sorry, how many beneficiaries?
Transactions, can it scale to? Can it do 1 billion a day? Because we're looking at these kind of numbers with 1.5 million refugees. The other question is, can it also not just do payments, but learning outcomes and then settle with some incentivized collection of meals or some kind of incentive? And what do you think? Can we connect later? Because it's a long question. Yeah.
Yeah, definitely.
And how do we become partners with you?
Sure. Get in touch. My email is there. And so on the first question, as I mentioned, we did our proof of concept on the test nets, but we're doing a private implementation right now, and we can handle quite a bit of transactions per second, so 1 million a day won't be a problem. In fact, we're shooting more for more, because WFP itself has 80 million beneficiaries that we serve in 80 countries. And we've heard over the past few days the efforts are in place to essentially speed up everything, potentially even the main net. And so we don't foresee the throughput to be a limitation either now on what we're doing privately or even in the future. And then, yeah, I mean, definitely that's, I think, the beauty of smart contracts, that you can program whatever logic you want into it. So, for example, we have school meals, which means that, generally speaking, let's say if a child attends school, then the child and the family gets food. So it's in a way to ensure children attend school and also that some nutritional outcomes are met. And with smart devices and everything, we can essentially sort of automate that so that, the entitlements go into a smart contract in escrow, and if certain conditions are met, then they're triggered to the end recipient or recipients. 56 seconds for a really quick one in case there is one. Cool. Thank you.
Okay, next up we have Julien Bouteloup, and he shall be presenting ID Box, cost-efficient device for self-sovereign identity. Sorry.
Hello, everyone. So today I'll be talking about something called ID Box. ID Box is it's a project for non-profit, building a foundation for identity in developing country. So I will try to stay high level because I don't have that much of time to go very technical aspect of the project. I would rather prefer telling you what we've been doing in developing countries around identities. First about myself, I'm a developer entrepreneur, and I've got a master in electrical engineering and master in computer science, and I've been building different projects around fintech, transportation, energy, all kind of projects. And then I will tell you why I'm telling you all of this. So the main problem worldwide, a lot of people already mentioned this problem, but you've got 1.5 billion people in the world that like official identification. And we're talking about countries where you don't have internet, you don't have electricity, and you don't have smartphone. So if you think about all those different startups that try to solve the identity problem by building a very fantastic smartphone application, for those people, it's not relevant because they don't have a smartphone, so they cannot really use the application. So we're starting to use blockchain, and we're building all this kind of crazy application, but still those people, they cannot really profit from the new technology. So for the past 9 months, I've been trying to build something that developing country could use in order to first create a unique identity and then access to different services. And the main goal is having a device that don't really need internet, don't need a grid electricity, and doesn't require a smartphone. And the people can use it by having either analog phone or by having a smart card. And also it has to be cheap, so everyone can actually buy it. And the private information from the user is not saved into a central database like the Estonian government is doing, or like the Aadhaar project from India. So I will quickly show you a video, what I've been doing. The video is 9 months old, so the project involved, but I didn't have time to edit the video, so I'm not sure if we can play.
ID Box is a cost-efficient device that enables people within developing countries to create a unique identity. The ID Box device is composed of a Raspberry Pi, SMS chip, fingerprint recognition, and a solar panel. By combining these components, it allows us to create a secure, identity-based service that will revolutionize the way that developing countries participate in a range of activities. From Papua New Guinea to Ghana to Samoa, we are able to ship the device to any local area, even if they don't have power or the internet. The devices, which cost less than $50, are hosted in a range of centralized areas like schools, churches, banks, and coffee shops. People use their SMS phones to text the ID Box device to create a unique mapping of their phone and fingerprint, creating a personal ID. Once someone has created an ID, they don't need to use the box again unless they want to assign their ID to a new phone. Across the country, millions of people do not have an ID. This is John. He has recently heard about ID Box. Using his phone and the local ID box, which is located at his nearby church, he is able to create a unique ID. He sends an SMS to the ID box to activate the registration process. He puts his finger on the fingerprint scanner. The box then encrypts the fingerprint using an advanced encryption process and then sends the hash of the fingerprint by SMS to the blockchain attached with John's phone number. If the identity doesn't exist, it then creates a new identity on the blockchain and sends a confirmation message to John on his phone to confirm his new unique ID. With his new identity, John is now able to view his balance, history of transactions he has made, and to securely transfer money to other people who have created a unique ID. Each time John wishes to make a transfer with other active users, his unique ID is verified against the blockchain. He is quickly notified of his transactions on his phone. He can also participate in voting systems, healthcare registration, and ownership of land. Thanks to ID Box, John's engagement with these activities has been revolutionised.
So there was the video from 9 months ago. So you can think about all the different problems. It's not possible today with a private key or unique key from a fingerprint. Well, it's not actually entirely true if you stay to your very local village and you use like kind of like fuzzy logic extractors and all this stuff. That's what we've actually been doing in 2 different places in the world. That was the first implementation of the ID box. Looks like a bomb, but it's not. So basically, you use iris sensor. You got the phone number on the bottom of the box. Don't text it. That was my mistake. I put the phone number, but now I had to delete it because people were sending me SMS. And you've got a SIM card on the right-hand side. So basically, the SIM card can be bought from anywhere in the world. So you ship the box to. This is the idea. This is the main idea, basically. You ship the box to any local area, and then they just have to buy a local SIM card to have either internet communication or SMS communication. And then the solar panel charge the box because you don't have electricity. And you can also add a password and information on the screen. Then I built this new version. That was the new version of the ID box, version 1, I called it. I went to Papua New Guinea to run a proof of concept. That was using private database for 3 different institutions: the Central Bank of Papua New Guinea, the microeconomy loan, and mobile providers. But the problem is this kind of box can be very easily hacked, and people can perform like if they try to copy a fingerprint from someone and then try to create a new identity. So then sorry, I forgot to remove the stuff. Then I raised quite a lot of money from private grants, not ICO. So with the money, it was quite a reasonable of money, but this was my new desk. So I moved from my desktop to my living room. And I built open source 2D printer. Basically, the idea was to build kind of open source the entire project and build that everyone can actually build the ID box to create a unique identity. So I designed and I put the file online so everyone can actually download them and they can play with the ID box. That was version 1 on the top. And actually, I'm the first one. I mean, ID box is the first one to create a first 3D printed Java card that everyone can print and modify and then can save like a personal token inside from a dairy fingerprint template. I will show you why it can be used for. So that's the new ID box. So you've got a Linux distribution system and a screen inside, rather than having just Raspberry Pi. Because Raspberry Pi, for people, they're not really technology. They don't interact often with screens and technology in a very remote area. So you have a screen and you can do different you can access different services. So you can enroll yourself, so you can create a unique identity, and you can use the box as a voting system or send money or receive money. So if you remember the previous presentation, they were talking about how costly it is to receive money for those people in the village. Most of the time they have to travel 6 hours into the capital to receive money from the son who, for example, works in Australia. So the son sends money to Papua New Guinea, to Western Union. Western Union most of the time charge 30-40%. And then the person in the village has to travel to the capital 6 hours, cost them about 100 the local money over there, which is almost the money they would receive from their son. So it's a complete disaster. But this they can use as a gateway for receiving money using an Ethereum card. So you've got the SIM card on the side, you got the solar charging port, you got charging ports, so people can actually sell electricity to other people in the village. Why is it important? For people over there, they've got analog phone, but they don't have system to charge the analog phone. So they need to travel 6 hours to the top of the mountain and find someone who's carrying very huge battery system, and then they buy the electricity. With this system, a local shop, they can actually buy the box and then sell the electricity back to the people in the village. And it's a modular box. So basically what it is you can increase the security. If you're talking about a big village and you worry about collision into creating your private or public key, then you can add iris sensor and blood sensor. You can add different biometric system. So using the multimodal biometric authentication system. At the end of the day, the private key obviously is never saved because you are the private key. That's the main idea of the project. And you can encrypt. Either you can sign whatever you want, like authentication system, using your own body. So Nick Johnson is over there. So I talked to Nick Johnson and a few people from the Eastern Foundation, like Gav and also other people from Swarm, etc. So I built this first ID box card with the help of Nick. And so basically, we've got like about the entire village now has got the card. So I can send you the unique public key of those people, and you guys can actually send them money without passing by Western Union. So it's direct money from them, which is very quick. And I've been working on something new. It's a ID box hard wallet, using a new Java card applet and using NFC and fingerprint. The USB token, I put it there because it was cool, but it's not actually functionable. And the idea is to basically use this card to sign transaction because those people, they don't have a smartphone. So the ID box will transfer the template or the private key to this card, and then the user can actually put his fingerprint on the card and then sign a token transaction and then verify into the box that it's a real person. The proof of concept. So I'm going to talk about this one. This one is really cool. So we decided to go to Papua New Guinea. I'm not sure if you guys know where is Papua New Guinea. It's on the other side of Australia, between, so you got New Zealand, Australia, and then a little bit further you've got Papua New Guinea. Papua New Guinea, why Papua New Guinea? If you look at the statistic, Papua New Guinea is probably one of the biggest countries in the world where people don't have their identity. It's about 90% of the entire population that are not registered, so they don't exist. So that was a big challenge. If we can build the ID box over there, if we can create identity in this village or in this country, then ID box can work everywhere. So we went there. It's about 5 hours. We got a little bit stuck on the way, like it was like 5 hours. And so imagine those people. First, they don't have a car. If they have a bike, it's probably impossible for them to go to the capital and then get funded, get the money from their son from Western Union, because they got to travel 6 hours. Sometimes they take the bus. I'll let you imagine what the bus would do in this, on this road. So the village, it was very fantastic. It's called La Lora. You can look online. And we registered people from the village, and they were really... so for the men, it was very interesting because they can sell electricity back to the people into the village. So they got an incentive of buying the box, because then they want to... if you can sell electricity by charging the box, then people are more... they want to carry, they want to take care of the box. And then, so basically what it does, you create your biometrics, send it to the card, and also the public key of first the Ethereum card is linked with your phone number and linked with your public key of your biometrics. And it's a village of 150 people. So the collision into the village is not very high, and you use also GPS-based location system. I know like proof of presence or proof of position is not very, it can be hacked. But if you add all this kind of biometric into the system, then you can make 100%, not 100% sure, you're never 100% sure, but that the person that was created was unique. And this is the local shop, the man. So you see we've actually done the first transaction. So this woman received Ethereum from the son, who's in Australia, and they went to the local shop to get the money. So I'm looking at the time. Coming features. So we've been looking into zero knowledge proof. So making, because the main idea about identity, which is very difficult to build, is You want to build a unique identity system, but at the same time, you don't want to share your information. So it's a bit contradictory. You want to make sure, I mean, any service for businesses like bank, insurance, and all these kind of big companies, what they want to do, what they want to know that they want to be 100% sure that the person they're dealing with is unique. That's the main idea. And they don't really care about your information. The only reason why they actually get your information, they ask for your information, is for them to make sure that you are unique. But if you can provide a system, first, if we can make sure that they are unique, then there's no need for them to take your identity. So I've been looking into, and also talking with Fabian as well, like is building the identity protocol into the Ethereum, which is fantastic. So you also like system where you can add multimodal biometric system like fingerprint, iris, and blood sensor. I'm saying that, remember that this information is not saved anywhere. That's the main idea. So only the derivative key or the public key is saved. And then you always need to go to the box to sign the transaction. Or if you use only the fingerprint with your card, then you can use the card. But you cannot use iris or blood sensor. I've been looking into something called, well, actually, I think we are the first one trying to do that, but it's called, I called it, named it the Identity AIM. It's basically like an ATM, but more like for identity system. And the roadmap, so we've done version 1, version 2, we're planning a second phase of the prototype in PNG. So we got big institution over there that following the project. I mean, actually partnering with the project. We've got central bank, all the mobile provider, insurance, micro loan, micro credits. So you can, all those different applications can obviously be used by the ID box. So it's for non-profit. So if you guys are very interested in trying or helping or partnering, if you're also building something with identity, it would be cool. Well, I think I've got time for a few questions. And if you want to, so this one was a non-profit project, and if you want to come this afternoon for, I'm building a flying carpet, so it'll be a different discussion, but that's it. That was the ID box. Good.
I'd like to announce bringing the non-crypto world into Ethereum through social impact. It's Jacob Wojciechowski and Raphael Mazet.
Hi everyone, I'm Raphael. I'm the CEO of Alice, and this is Jacob, who's our CTO, and we're here to talk today about what we've built. And how we're helping the non-crypto world come onto Ethereum using social impact. Oh. Yeah, so really briefly, I'm going to give a quick overview of where we are, which is that we've got a transparent donations platform that's been live since May on alice.si, which is our website. Then Jacob is going to run you through how we built that, the hybrid model that we use to bring mass audiences onto the platform, and then I'll just give you a brief overview of the next steps for Alice beyond donations. So if you know Alice, it's because you know our transparent donation platform. And the idea there is that you can give to a social project. You can see exactly what impact your money makes, and if it doesn't make an impact, then you get your money back. And the project that we have live on the website right now is a project run by a homelessness charity called St. Mungo's, and they are helping 15 rough sleepers in London find accommodation and deal with mental health issues, substance abuse issues, and the way that the reason why we built this really is because in the last few years there's been a loss of public trust in the charity sector, and the charity sector is really starting to see this as an existential threat. Because without trust, the level of donations tends to fall. And so that's why we built this donation platform. The way that it works is that when you go onto the website, you can donate. Your donation gets held in escrow, which means it gets frozen, basically, in a smart contract. During that time, the charity can start running the project and start delivering the goals that it set out to achieve. So it lays out in the pilot. St. Mungo's has laid out a certain number of goals, but it's only when the goals are independently validated that the money from the donations gets paid to the charity. And in this case, it's the Greater London Authority, that the Mayor of London, someone in the housing team that reviews the proof. So if that's a rental agreement, for example, if someone's found accommodation, then they will validate that. And at the same time, the validation triggers a notification to the donor, so they know exactly what their money has paid for.
Now I'm going to tell you how we implemented the whole solution. So we wanted to design the donation platform so it's really easy to use for mainstream donors. You do not need to know how the blockchain works. What is the blockchain? All what is necessary is to have a plain old browser, even without any plugin. So there's no need for complicated tools like a Mist browser. And as the whole world mostly uses fiat currency, we do not want to force our donors to change fiat into crypto, get through a crypto wallet and donate. We allow for a plain credit card donations, which is the most popular way to donate. And let's see how it worked out in the practice. So that's one of our first donors. Actually, it's my mom. She's she's 67 years old, and she's not a crypto geek at all. She stopped catching up with the technology in the late 80s when the video tape recorder was released, but she knows how to use internet. She knows how to write an email, check the weather, and recently she was able to put 3 transactions on the main Ethereum blockchain using our Alice platform. How was this possible? So whenever a user registers an account on our platform, we, on the user behalf, create an Ethereum account, which is safeguarded by a password. So every interaction, every transaction needs to be signed by re-entering the password. We also perform fiat tokenization. So when we accept the money, there is stable coins issued that are pegged one-to-one to the original value, and the full reserve is kept aside. And we are happy to say that earlier this year, we took a part into regulatory sandbox provided by Financial Conduct Authority, which is a UK regulatory body, And to our knowledge, we are the first company to use fully regulated digital pound sterling provided by Tramonex Labs. And from a user perspective, the transaction is recorded after he clicks on the donate button. And then we use an asynchronous relay just to further process the transaction and put it on a blockchain. And this solution proven to be quite useful because roughly a month after we launched, we noticed some strange behavior in the relay. So there were severe delays and a lot of retrials. And it was the day, 20th of June, when there was a status, ICO. So from the point of view of our donors, nothing changed at all. They were able to submit donations and we processed it asynchronously, and they were eventually recorded on the blockchain. And to be honest, we were super scared before we started the pilot because we are all about trust and transparency. So even if we mismanage a single transaction, that would be disaster for the whole idea. That's why we are using a triple registration system. So we register donation on a virtual wallet provided by a payment provider. We register on our classic database, and we obviously register it further on the blockchain. Currently, we have a hybrid model, but we want to go for a fully decentralized and a trustless solution. But along the way, we want to take small steps, not to sacrifice the usability and safety for the donors. The next step for us was to implement something that we call the geek mode. It's a section on our platform, then a user can browse and explore all of the transactions that were made with his interactions. And for users who has a plugin that allows to connect to blockchain, like a Web3 connector, we got a very simple dApp, but with a restricted read-only access that you allow to check a balance and what goals were achieved by these users. And before we allow our donors to enter the wild west of the blockchain, we want to equip them with a safety features. Like one of that is a donation wallet. So all of the transfers outside of the wallet can be directed only to authorized, verified projects, because we want to shield the users against scam attacks. So if they receive offer to donate via Slack channel or email from an untrusted account, they will be unable to process. And donation wallet also offers a way to recover if the password was lost. So we can set up a multi-sig recover procedure. So in a case that you lost a password, you are still able to set up a connection to a new account. We also focus on the security of the funds that we are collecting. So we add extra features for our treasury, like a two-phase transfers when they need to be initiated and validated later on. The transfers can be time-locked. We also introduce a special role of a whistleblowers that may raise an alarm if the transfer looks suspicious, but without any acting power, because the acting power is in the hands of a curator who may refund the transfer. We also use classic features like pausing or freezing the treasury contract and escape hatches in an emergency. And as the project in practice are evolving and iterating, and if a charity cannot achieve all of the goals, it is possible that charity submit a proposal update that is later on voted by donors and beneficiaries. And if the cost is valid, the configuration of the project may be changed. We built an abstract layer around our data. So we tokenize that in a form that we store meta information about who was the author of the data and what are the access rights. And the full evidence is kept in an off-chain encrypted database that is synchronized and notarized on the blockchain. Why do we need such a structure for our data? I will let Raphael to explain.
Yeah, so this has to do with the broader vision of Alice, which actually goes beyond donations. And obviously, transparency is really important for small donors because they're losing trust in charities. But it's actually also important for a whole host of other social impact actors. For example, big philanthropic trusts and foundations, they are increasingly giving grants based on evidence, so it's very important to measure that. Governments in the UK, the US, Europe, and increasingly other countries shifting also their grants to payment for success models, where they only pay when social outcomes have been achieved. And then over the last 10 years or so, there's been a real rise in an alternative source of funding in the form of impact investment. So what impact investors do is when they invest, obviously they're looking for a financial return, but they're also looking for a social or environmental return, which means that it's really important for them to track that data. And the big problem is that, unfortunately, when it comes to impact data, we're still in prehistoric times. Everybody is systematically reinventing the wheel. Everybody is measuring things quite differently. The standards that exist aren't really widespread. And really importantly, all of that data tends to get stuck in the individual databases of all of these organizations. So it makes it really difficult to access and compare and benchmark projects to see which ones are the most effective. So we are going to build 3 main evolutions on the ALICE network. The first one is really starting to break down what goes in that impact data. So we're going to require that social organizations break down their projects across 5 dimensions. Those 5 dimensions have been developed by the Impact Management Project, with who we're collaborating. It's a big open source research project that's done some research amongst over 700 practitioners all around the world to build a framework for how to measure and manage impact. Effectively, the projects will be tagged across those 5 dimensions. And we're also going to require social organizations and projects to produce regular progress reports against internal performance indicators. And the way that we're going to enforce that is that they will be rewarded. They'll get paid for submitting those reports. And if they don't submit them on time, say for example, then they will be punished with all further payments withheld until they do. And that payment for reporting is actually also at the core of what we do, because what we're going for is not making impact projects cheap, but effective. So you're probably familiar with this kind of pie chart that social organizations produce, showing exactly how much money goes to admin, how much money goes to PR or fundraising, how much gets to the front line. And actually, we don't think that that's the most important thing at all, because it doesn't really tell you anything about how effective they are. What we prefer to focus on is tracking the impact. So how many people have been helped? Is this social project actually improving the lives of the people that it serves? So we're not tracking the money, we're tracking the impact. The second major evolution to the network is that we are going to incentivize users to take all of that impact data that's been produced by all projects across the network and crunch that data so that you can really surface the most effective projects so that funders can help scale them. And we're also going to build prediction markets that allow users to bet on whether the proposed changes to projects that are submitted in the regular progress reports, for example, are likely to increase or decrease the impact of those projects. And the idea there is to crowdsource the expertise of people across the network to really help charities learn from each other and iterate their projects to really make them as effective as possible. And finally, what we are going to build is another payment module that's focused on impact investment. Because what we have right now is that donors give to the social projects. Those funds are held in escrow, and they're only paid out when the goals are validated. Now, the problem there is, especially if you're a smaller charity, you might not have the financial resources to run your project before getting the money. So that's where the impact investors come in. They will provide some working capital, some seed capital that they will give to the project so they can start running them. Effectively, what they'll be doing is underwriting the risk. So if the project never produces any results, if it never achieves its goals, the investors will lose their money. But if it does achieve its goals and it gets paid from the donations in escrow, then part of those donations will go to reimburse that investment. So that's pretty much it. That's the broader vision. We're building a fully integrated, decentralized social impact ecosystem so that social organizations can tap into donations and grants and impact investment so that their impact is properly managed and transparent and accessible, supported by validation markets so they can easily choose validators for their projects, whether those are human validators or oracles, and by knowledge sharing markets that help crunch that data and surface the most effective projects. And that's really what we're all about, is really identifying the best projects, helping them scale, and cutting transaction costs across the network. Now, we've just published our white paper today, just a few hours ago, so we invite everybody to go onto our website and read that. It covers everything that we've just explained in a lot more detail, as well as some really interesting stuff that we're building as well that you'll be able to read about on the white paper, like a decentralized fund to help smaller organizations really design and run their projects transparently on the network. Thank you very much. If you have any questions. Thank you.
Over here, please. Question. Sorry. Over here. Hello. Hi.
Yes.
This is quite a tedious little question, actually. Just the matter of issuing receipts to donors. I've always found that to be just a real pain in the backside, particularly if it comes via a bank account. So does your module have, what do you do by way of how do you issue receipts to your mother once she's paid her donation?
So that's something that we actually spent a lot of time on. Currently, the platform can be used only in the UK, and we went through all the regulatory hoops to make sure that people could get receipts when they donate. They can actually apply gift aid, if you know how that works in the UK. It's a way of gifting the taxes to the charities. And we had to get the regulatory authorizations to do that. It gets applied when the donations come out of the escrow, because you can't claw it back afterwards. But then, obviously, as we expand to different countries, we'll have to figure that out on a case by case.
Hi. Sorry to be a little more critical and harsh on you, but how I saw the presentation is more like you're doing a charity ICO instead of actually empowering civil society to perform social causes. And it looks to me that like you're commercializing civil society actions, which I think it's quite a slippery slope from a civil society point of view. And I also want to point out that not far from UK, 3 hours flight from there, in Romania, there are only 6 or 7% of people buying online. So you also have to take this into account, that other countries are not so used to paying online. And this transaction is not going to have that big of adoption rate. And also, in terms of terminology, when you say donation, it traditionally points to a gift. You're giving money to someone or to an entity, and you do not necessarily ask for something in return. While in this model, you ask for performance. So I would suggest turning a little bit these terms around, because donations are gifts, and this is not what you're doing in this model.
So just on the first bit, on the commercialization, I didn't quite get where you see the commercialization of charity there.
When you put a high pressure on different activities performed by civil society for receiving that type of money.
Right. So it's not so much commercialization as just tracking the impact. So I think all of your points are absolutely valid. I think the reality is that the lack of trust or the decline in trust is very real. And unfortunately, what happens is that then people get completely obsessed in this really toxic debate around how people spend their money. And that's what I was referring to before. How much goes to admin? How much goes to fundraising? And that, for me, is actually completely counterproductive because it leads to charities trying to be as lean as possible. They end up underinvesting. They can't pay high-quality people to run projects. And so that's why we track the data. So, and the performance. The way that we mitigate what you're saying, that's where we bring in the impact investors. It's also, we're going to implement some models where not all of the money gets paid when the impact is achieved. So you could have a model where half of your donations get paid to the charity up front, and then half of the payment gets paid upon achieving the results. But really what it is just an incentive mechanism to make sure that the social organizations deliver on the impact that they promised, essentially, and restore that trust. And ultimately, what we want to do is just help them raise a lot more money than they are raising at the moment, so they can really tackle social and environmental problems at scale. And I think on the last point, or the second point that you made, which was a lot of people don't donate online, that's true. But you know what? A lot less people even donate in crypto. So that's why we're adopting a hybrid model. It has to be online for the incentive mechanisms to work, and hopefully, as online giving becomes more widespread, then they'll be able to spread it out to a lot more countries and donors. I hope that answers your questions.
We'll discuss more in detail.
Okay, I look forward to it. Thank you.